Hi everybody, welcome to the campus of Central Washington University. This is another geology video, this time focusing on Lisa Ely. Professor Ely has been on campus almost as long as I have. She's teaching geomorphology this afternoon. Let's drop in for a visit, see what those guys are up to. Thanks for joining us. Okay, oh, you're doing a time lapse.
I just turned it off. So yeah, it turned it back. So, same channel. We're doing different things. So, we just want to do then every 15 and every 20 minutes.
See that big block? Make it diverge around it.
So you got some initial idea of how the rocks affected the channel?
Yeah, so if you have like big boulders in it, the stream will go around that instead.
So did you were just doing your kind of, let's see what happens run?
Yeah.
Okay, well that's good.
Yeah, we should ask for it first. Oh yeah, we need to ask for it. Maybe not permitted.
So what's your hypothesis here?
We're doing the amount of with spacing of step pools to see how much sediment gets down
Okay, how are you going to make the step pool?
with the logs.
So you're going to have log jams, basically?
Yes.
Okay.
So so for the first run we'll do nothing, none,
Control.
base run, and then for the second we'll do every spacing of every 50 centimeters, and then for the final we'll do every 25 centimeters, so there's even more.
All right. Sounds cool.
And the idea is that with more of the steps, you'll have less sediment going through because
Okay.
it's stuck at the steps.
So there's your prediction.
Yes.
More steps, less sediment yield.
Blake, why did you build there? That does, Blake, you kids.
It was prime real estate at the time.
Ah, see?
Yeah. Tough. And I moved down there.
Oh, your clothes.
It went over there again. So it's that
There,
first bend.
your clothes not getting up the tube anymore.
Oh yeah, stop it.
Oh, you stopped it.
Yeah,
Well, that's
yeah,
why.
I kind of wondered if this is
Okay.
yeah,
So you're doing a short run.
Stepping logs for the next one.
So like, you guys just playing, or is there some sort of method here? What's going on? Like, seriously.
This is our base. This is our control.
Okay.
We aren't putting in any steps, so we're just after 2 minutes we're seeing how much sediment is reaching the end.
So you're literally measuring how much sediment gets washed into the bucket or whatever?
That is
And
all of the experiments are something to do with how
I
much
see.
sediment gets there.
Okay.
So we're just changing ways to reduce sediment, basically, or enhance.
That's pretty slick.
I just really like how the sediments are different colors for the sizes. So you're saying all of the yellow go in first because it's the biggest.
Yellow are bigger than the white, bigger than the black.
Yeah, and then at the very end, red.
Yeah, there's some red.
Red are the tiniest. Yeah, that's pretty clever.
Concentrated up there.
Oh no. Oh no.
Oh, our water is changing.
It's turning into a braided stream, I guess.
So do we let it happen like that every time?
I think we have to.
We have to. Kind of have to let it go.
Got
Well, that could change our
20 seconds.
if this doesn't happen every time.
I mean, we did a straight channel and it broke like every time.
Well, guess we'll find out.
Okay.
But this is
Sound
really
is
braided.
in.
We didn't use this.
Yeah, look, it completely stopped doing that channel.
4, 3.
I mean, that's a good example of what rivers do, I guess. I mean, like, well, actually, no, I guess there is some.
Okay.
There's a little bit there.
Yeah.
Oh, you stopped it? Nice.
It looks like it's going through the groundwater.
Yeah, no, like it's going through, now it's, yeah, you can see it pulling up red. Yeah, you
Should have asked for my emergency TA to come back today.
Oh, the TA thing, I forgot. Right, okay. So So that's a mixture of our geology majors and then like some geography folks or environmental studies type folks.
That's right.
Yeah.
There's some biologists in there too.
Yeah, I didn't know, like a bunch of those cats, I guess, yeah.
Yeah.
So that was their first time using the stream tables? It seems like they
It is.
kind of knew what they were doing, like you've maybe built up to that or something in lecture or something, they kind of knew what their plan was?
I did. We
Yeah.
talked about the plan.
Yeah.
They've stared at those stream tables all quarter,
Right.
but this is the first time we turned them on and they got to actually experiment with them.
Good.
Yeah.
Well, how have the labs been going? You've been doing field things, I know, kind of regularly. So where were you guys in previous weeks out in the field?
Well, let's see. Last week we were at Umtanum Creek
Okay.
and they did surveyed some stream channel cross sections and they calculated the velocity and the size of sediment that could be picked up by different flows in the stream. So
Yeah.
what flow is actually eroding and depositing sediment in that stream channel. The week before, we had 2 people from the U.S. Geological Survey come, show us how to use some of their fancy equipment, talked a little bit about careers in the USGS.
So how did you snag USGS people to come to our campus?
Well, one of them is one of our graduate students, Riley Blanchard,
Nice.
and then he talked his supervisor into coming. They came up and spent 2 days here and worked with both the labs, and that was a big success.
Well, that worked out well, didn't it?
Yeah.
So you've taught geomorph pretty much every spring, right? For more than 20 years.
That's right.
And you've had both undergrad and grad TAs. You've had a number of kind of grad students under your tutelage over the years.
Yeah.
How would you, what's the through line for all those grad students? Is it all river related? Is it I kind of forget now. Like
There have been some landslides in there,
Yeah.
some tsunamis,
Mm-hmm.
and a lot of river people, and now I'm getting a little bit into groundwater and interaction of the river, surface water, and groundwater in floodplains.
So you came here in the mid-90s.
That's right.
And Vic Baker student, University of Arizona.
Yeah.
Do you remember what you visualized when you first came here? Like we just dealt with Hannah, and like she's got these plans, and she's got a grant right away to kind of work. Is your kind of work evolved over the years, or you kind of knew what you wanted to do up here with your grad program?
It has certainly evolved.
Yeah.
I did come with a grant to work on paleo floods in India when I first got here.
Oh, that's right. Yeah.
So that got going, but I wasn't really confident enough to bring students to India with me at the beginning. I did bring some later.
Mm-hmm.
It just kind of evolved with time.
Yeah.
Things happen, you get to work with somebody new, they have some ideas, it kind of goes one way or another way.
Right.
I never anticipated I'd be working on earthquakes and tsunamis, but now I have been.
Well, tell us about that. Like you made a number of trips. Was it Chile?
Yes.
Yeah. And how did that come about? And so you've had grad students come in to work with you here in Ellensburg, and then they're going down to Chile for field work?
That's right. Well, it started actually because of the floods in India, and then there was a big tsunami in the Indian Ocean, and through various contacts I got invited to go on a trip to look at tsunami deposits in India because I had contacts with people there.
Oh, I see.
And my initial thought was, I don't know anything about tsunamis, but Brian Atwater told me, well, that's just a flood going the other direction up the river. He's like, you understand floods. So I was like, okay, I guess I can do this.
Nice. So Brian was with you in the field at least once.
He led that trip to India.
Okay.
He organized it,
I see.
invited me to come. And then on that trip was someone from Chile, Marco Cisternas, and I ended up collaborating with him then several years subsequently on tsunami deposits in Chile. Then when Bree McInnes came here,
Yeah.
she joined the team. And now Walter Saliga might come with us this
Oh,
July.
good.
He's been working with students on that too. So it's been fun to get the newer faculty involved in that.
Well, yeah, I mean, you've just been so, I'm just remembering now talking to you, like, yeah, that's quite a range of projects you've been involved with, and you've just been kind of open to working with whomever, it feels like, and using
Well,
your expertise.
the through line is I've worked with so many really smart and accomplished people, and you know, I bring what I can, but I try to learn from what they're doing, and you know, I don't know everything about all these things. That's why Bree, who understands modeling, and Walter, who can write these new tsunami computer flow models,
Yeah.
they get involved in their part. I see myself as the facilitator, as bringing these people together.
Well, this is the modesty portion of the interview, so that's good. I mean, we know that you have tremendous strengths as well, but yes, I mean, it is the collaborative nature of that, and so the whole reason for these videos is to have some potential grad students or maybe even potential undergrads going, oh, I didn't know they were doing that there. That's kind of cool. So you've had plenty of undergrads out of this course
Yeah.
you're teaching right now, for instance, and you
That's
kind
right.
of, I don't know, how does it work? Do they approach you, or do you kind of approach them sometimes about, hey, I've got this
Yeah.
undergrad program?
Kind of
thing?
both. So if I have a project or I have a graduate student who needs some field assistance in the summer, this
Yeah.
is a good course to find people who might be interested in that.
Mm-hmm.
Some of them, so they do a final research project in the class,
Okay.
and I've had several that have then continued that over the next year and elaborated on it.
I think the message to a lot of these young folks is that you don't have to have this very specific career plan in mind, or like, don't you
No.
get like concern from students like, I don't know what I'm going to specialize in, and I don't know
Right.
what my job's going to be. I don't know, how do you handle that set of questions? I would just say, this is general on purpose. You're just trying to like get as much fundamental geology
well,
together as possible.
I've been talking with a lot of students who are applying this year
Uh-huh.
and asking those types of questions. And, you know, I usually say it's only 2 years of your life doing the master's.
Yeah.
And really, it doesn't matter that much what you work on. The main thing is that you're gaining these skills of seeing a project through from beginning to end and
Yes.
communicating your results.
Yes.
So if you learn to use a particular piece of analytical instrumentation, then an employer knows you're trainable to use some other
Right.
instrument.
Right.
If you learn to use a computer program, then you have the confidence and ability to learn another one that you need later for some specialized job. So it's not so much which one you learn, but just that you get the experience of learning the tables.
So what have the stream tables been extremely useful, or is it more?
Yes.
It is. So,
Yeah, they're useful because they show these processes really rapidly that might take years in a stream. So they can measure something, they can change something, and then see the effects right away. But they've also been really fun. They're great for outreach.
Yeah.
Everybody who's tall enough to actually see over the lip just loves working with them. So we've done them with lots and lots of outreach. And they're always a big hit.
Wonderful. Thank you.
How are things perking away here? Anybody done an actual, real run? Collected the data? You did one? Okay, you're doing your control. How about you all? We got Justin.
This is our third base run.
Okay, your third control run.
Our third base run.
And then remind me what you're varying. Okay.
50 centimeters in the next.
All right. Okay. So you're making kind of the step pool. And we're monitoring the sediment coming out here to make sure it doesn't overwhelm the system.
This one's doing more of a meander. Our first one broke and went like this way, and then the other one kind of like was this whole area of water, but this one's a very nice bend right there. Different every time.
So maybe you see, yeah, part of it is the reason you want to do at least 3 from each setting is to see what kind of variation is there when you think you've got everything set up exactly the same.
Exactly. If we had built up a wall, we made it a bit more.
There could just be some randomness involved.
The last one we did, it actually built up a little bit of dike and actually.
Okay, so it built a channel levee. Neat, that's a beautiful pattern. Thalweg coming around there. Okay, I don't want to get in the way.
Is there any carryover from the tandem stuff last week? Like, were they looking at channels or anything like that?
They were looking at a channel. Any carryover from last week?
Yeah, not entirely with our experiment, but definitely looking at the sediment size and stuff and where it's located. Last one we had a really cool point bar, and yeah, it's really cool. The colored sediment is definitely worth it.
Well, I don't know about $20,000.
If you dig down, you get the red sediment. It tends to go down to the bottom because it settles down to the bottom. You have to kind of really
Well,
stir
yeah,
it
one
up.
of them, like, you could see it was just moving the red. Like, everything else was kind of stuck.
But when you're redoing it like this, you can scoop it up and get it mixed in there. Then you'll see more of it in the end. All right, how about this group? Okay, so it helps to experiment a few times. Just run it a couple times and see how you want to set it up before you say, okay, now I'm ready to take the serious data. Because you have to experiment around with it a little bit. It's not done in a vacuum.
It says that these machines, like, you have to start off at full power.
You don't have to, but it helps to get the water up there.
Yeah.
But then I usually turn it down immediately after getting it up there. You can start it at...
I didn't know that.
Did you come thinking you'd do some Ice Age flood stuff? I mean, you were working with Vic Baker. Like, that was... What'd you do your dissertation on? It wasn't Missoula floods?
It was not Missoula floods.
Okay.
It was just normal floods.
Yeah.
Kind that are produced by rain and snow today.
Did you seek him out? Did you really want to go to Arizona to work with
No,
Baker?
I'd never heard of him before I went there.
Okay, all right.
I didn't know anything. I went there. I had done an undergraduate research project on pollen and climate change, and I wanted to do that. And so Arizona was one of the places that did that, and also Minnesota and Wisconsin, your alma mater.
Yep.
And I made this decision in February, and I sort of thought, Arizona sounds like kind of a neat new place in a different part of the country, because I was in Illinois at the time. So that that influenced my decision. And then after I started studying pollen and I looked through the microscope for hours every day, I thought maybe something else would work a little better, and that's when I got into geomorphology and rivers. And I still think pollen is a really, really cool tool, but I don't want to be the one who looks through the microscope and does it.
So that field work is another through line, like you're always
Yes,
out.
I like that.
Yeah.
Yeah.
And we didn't have the grad program at that time. So did the grad program really change everything for you? Like, you showed up to maybe just mentor undergrads
Yeah.
and maybe do a little bit, but the grad program...
It did change things a lot.
Yeah.
Yeah. I think it's changed it for our whole department. You know, for the undergrads, seeing what the grad students are doing, that they can do those kind of research projects. I mean, hopefully just doing these experiments here gets them thinking about, oh, you change this, and then this happens, but now this new question comes up, and what if we want to look at that? You know, just getting these ideas, and then they see these graduate students who are doing that on a larger scale.
In here in the Northwest or even beyond that?
Interestingly, a couple of them are my graduate student peers, people I've known since graduate school. Jim O'Connor, who I met the day I moved to University of Arizona, started the same day, and we're still collaborators.
Yeah.
Kyle House, who's also with the USGS, came a little bit later while I was still there working on my PhD. He started his master's. We're still collaborators, actually Jim too, so he joined that group.
Right.
Ellen Wool, who's at Colorado State, was my office mate Sarah Rathburn, also at Colorado State. We wrote a paper together this fall. So yeah, a lot of those relationships that I developed in graduate school, and of course Vic Baker, who was my advisor, and then, as I mentioned, other people who I've met along the way. Some from the Northwest, certainly, who I met after I moved up here, Brian Atwater. Let's see, who else is Josh Roaring at University of Oregon, who works on landslides, collaborated with him. And then, of course, people here at CWU, not just in geology.
Right.
But Megan Walsh, I have a paper with her. She's in the geography department.
Yeah.
Bree Walter, one of my grad students, Pedro Matos Yavona, just wrote a paper that had co-authors, myself, Bree McInnes, Walter Saliga, also 2 other former CWU grad students were co-authors on this paper together. Oh, no, and I should mention another former CWU graduate student, Tina Dura, who's now a professor at Virginia Tech, and her graduate student. So we all worked on this paper together.
I mean, that's what you end up with. You know,
Yeah,
you get this
a
dense
network.
network. Exactly. Right. And, you know, we've been at it a while, right?
Yeah.
So there's connections galore. And
Well, it's very exciting to me that Tina, who I'm working with, and who I've worked with when she was a master's student here a little bit. I really started becoming a colleague of hers when she was at her PhD at University of Pennsylvania. She's now a professor. We still work together, and now she has one or two of our former students are her graduate students now. So that's really cool to me
It is.
that it's going on.
well, you do it all, and you have done it
yeah.
all for a long time. You have. Come on, Lisa, man, you're in the trenches every day, digging in this frickin' sand.
Yeah, we're digging in it. They got a nice pattern going over there.
Thank you for your
Yes,
time.
you're welcome.
Appreciate it.
If you add just a little bit of water to that, you can kind of settle it down, and then you can get a really accurate reading.